Good morning to all. Our today's topic is forwarding and reversing of three-phase induction motor. So in this PPT, we will see how to change the direction of three-phase induction motors. In case of single-phase induction motor, we can't change its direction because they are not self-starting motors. They don't have rotating magnetic field. In case of three-phase induction motors, they are self-starting motors. They have rotating magnetic field. Means the direction of rotating magnetic field will decide the direction of the rotation of three-phase induction motor. In case we change this direction of magnetic field, we can change the direction of rotation of three-phase induction motor. So the method we will discuss in coming slides, it is only for three-phase induction motor. We can't change the direction of single-phase induction motors. So to change the direction of three-phase induction motors, we have to exchange its any two phases. For example, if the phase sequence is RYB, then we can change it to BYR. The position of Y is same. We have exchanged the position of D and R phases. Now the direction of the motor will get reversed. So this can be accomplished by using two contactors. Basically, it is a contactor related circuit. So by using two contactors, one for the forward rotation and another for the reverse rotation. So in coming slides, you will see that we are using two contactors for changing the or for reversing the direction of three-phase induction motors. So here it's the wiring diagram for reversing the direction of a three-phase induction motor. Here we are using two contactors A and B. Contactor A is for forward motion, let us say, and contactor B is for the reversing the direction of the motor. When the contactor B is energized, all of its contacts, those are normally open, all its contacts are normally open contacts. As you can see, its auxiliary contact B is normally open and its free contacts, its main contacts are also normally open. When the contactor B is energized, all its contacts will get closed. Now the motor is getting supply as a phase sequence R, Y and B. In this case, the contactor A is bypassed. In case contactor A is energized, so this is for the forward motion. So in this case, you can see now the contactor B is bypassed. Now its contact will get open. Now the motor is getting supply from the contacts of the A, which were normally open, but after energizing the contactor A, all its contact will get closed. Now in this case, we have reversed two phases, that is R and B. Phase Y is intact. So the R phase now connected to the Y phase. You can see in this diagram, and Y to the Y because it is intact here, and B to the R. So we have interchanged two phases, that is R and B. So in this case, the motor of the direction of the motor will get reversed. Now let us check how it gets reversed. F1, F2. This is for the forward motion. When we push the F1 button, it's the push button, F2 will get open. Now F1, which was normally open, it will get closed. Now the motor is getting supply from O, F1, from F1 to R2, which is normally closed contact, and from R2 to the A. So in this case, the contactor A will get energized, closing its contact. And we have discussed how the motor is getting supply in such case. So if we want to reverse the direction of this motor, we will press R1. When we press R1, R2 will get open. So when R2 will get open, the contactor A will get de-energized because it was getting supply from this R2, which was normally closed. From this contact, it was getting supply. So when we press R1, R2 will get open and the contactor A will get de-energized. Now contactor B will get supply from O, then to R1, which is closed now, from R1 to F2, which is normally closed, and from F2 to the contactor B. When this contactor will get energized, its contact will get closed, and we have already discussed that in such case, the motor will reverse its directions. So let us see its schematic diagram. So this is a schematic diagram. So we have F1, F2 button for forward motion, R1, R2 button for reverse direction. So F1 is normally open, F2 is normally closed. When we push F1, F2 will get open. Same is the case with R1, R2. R1 is normally open and R2 is normally closed. When we push R1, R2 will get open. And small a is the auxiliary contact of A. When we press F1, the A will get supply from O, F1, R2 and A. In case this A will get supply, it will get energized and it will close its auxiliary contact small a. Now the contactor A will get supply from O, small a, R2 and A. So in this case, motor will run in forward direction. So R2 is the closed contact of the R1 button. So if we want to reverse its direction, we will push R1 button. In case we push this R1 button, R2 will get open. As soon as R2 will get open, the contactor A will get de-energized. Now in this case, when R1 is pushed, now the contactor B get energized through O, R1, F2 and B. When this contactor B get energized, its auxiliary contact B will get closed. Now this contactor B is getting supply from O, small b, F2 and B. And you can see that we have connected thermal overload relay between the contacts of A and B and the neutral. So this is all about how we can reverse the direction of a three-phase induction motor.